Students, this is Sivakumar, 11th Standard Mathematics, Chapter number 1, Exercise 1.4. In Exercise 1.4, we are going to study about graphing functions using transformations. Here, we are going to discuss about reflection, translation and dilations. Reflection, translation, dilations. We can see one by one. Start with the reflection. The reflection of the graph of a function with respect to a line L is the graph that is symmetric to it with respect to L. So a reflection in the mirror image of the graph, where the line L is the mirror of the reflection. Now look at the diagram here. F dash, this part of the curve is the mirror image of the curve F. Here L is the mirror. Understand? F dash is the mirror image of the curve F with respect to L. Here L is the mirror. This is called the reflection. It is given clearly. Here F dash is the mirror image of F with respect to L. Every point of L has a corresponding image in F dash. Right? Some useful reflection of y that is equal to f of x are given here. First subdivision, the graph y that is equal to minus f of x is the reflection of the graph of f about x-axis. And the graph y that is equal to f of minus x is a reflection of the graph of f about y-axis. The third one, the graph y that is equal to f inverse of x is a reflection of the graph of f in y that is equal to x. We have three types. Right, for the first type example here it is, for the curve y that is equal to x squared, this is a blue color line, blue color graph, that is y that is equal to x squared, and y that is equal to minus x squared. This orange color graph is the mirror image of the blue color graph with respect to x-axis. That is given in subdivision number 1. Okay. So minus y that is equal to minus f of x is the reflection of the graph of f about x-axis. This is y that is equal to f of x. This one is y that is equal to minus f of x. X squared minus x squared about x-axis. Reflection of the graph about x-axis. It is given clearly for the graph f of x equal to x squared minus f of x. That means minus x squared. Minus f of x that is equal to minus x squared. So y that is equal to minus x squared is the reflection of y equal to x squared about what axis? X-axis. Now second one, here it is, second subdivision, y that is equal to f of minus x is the reflection of the graph of f about y-axis. You are given, look at that example, y squared equal to x and y squared equal to minus x. Consider the positive branches of y squared equal to x and y squared equal to minus x. While taking square root, if we take square root, now y that is equal to plus or minus root x. Y squared becomes y. Here root x will be getting plus or minus, but what is given here? Positive branch only. So y that is equal to, I write over here, y that is equal to plus or minus root x. Here y that is equal to plus or minus root of minus x. Here we are considering only positive branch, means y that is equal to root x, that is a positive one. Here y that is equal to plus root of minus x. So y that is equal to root x and y that is equal to root of minus x. Okay. Look at the diagram. The blue colored graph, that is y that is equal to root x. Orange one is the equation y that is equal to root of minus x. That is the reflection of y that is equal to root x about what axis? Y axis. Again, the orange color graph is the reflection of the blue color graph y that is equal to root x about y axis. It is given clearly. So f of x equal to root x, f of minus x equal to root of minus x. Hence f of minus x equal to root of minus x, which where x is less than 0, is a reflection of f of x that is equal to root x about what axis? Y axis. We are given x less than 0 in this part, particularly the orange color graph. No, here x value is not all negative, correct? Here x value is not all positive, here x value is not all negative. That's why you are given x is less than 0. Now, third subdivision, here you are given the graph of y that is equal to f inverse of x is a reflection of the graph of f in y that is equal to x. Okay. Here the example, consider the function y that is equal to e power x and y that is equal to log x with base e. Now that green color graph, that is y that is equal to e power x. The blue color line is y that is equal to x. It is passing through the origin and lies in first quadrant as well as in third quadrant. Orange color line is a reflection of orange color graph is a reflection of green color graph about the line y that is equal to x. It is given here y that is equal to e power x is the inverse function of y that is equal to log x. That only given in subdivision number 3. Inverse function. Don't say f power minus 1, that is f inverse x. Have to read like this. Hence y that is equal to e power x is a reflection of y that is equal to log x about the line y that is equal to x. Now can go for translation. A translation of a graph is a vertical or horizontal shift of the graph that produces congruent graphs. Here we have 4 subdivisions. The graph of y that is equal to f of x plus c. C is greater than 0. The constant is added with x, causes the shift to the left, and the constant is subtracted with x. Always c is greater than 0, positive only, causes the shift to the right, and the constant d is added with the function. Look at the difference between these two. Here the constant is added with x, here the constant is subtracted with x. Here constant is added with the given function, here constant is subtracted with the given function. In third case causes the shift to the upward, and that fourth case causes the shift to the downward. We can see one example. Consider the function f of x that is equal to modulus of x. That blue color graph, that is modulus of x, y that is equal to modulus of x. Then orange color graph, that is y that is equal to modulus of x minus 1. X minus 1. Here look at that. 1 has been subtracted with x. 1 has been subtracted with x. So we can go for this type, second type. So c has been subtracted with x means causes the shift to the right. Look at that. Now 0 has been shifted to 1 by 1 unit, because what is given here, what is the number here? 1. So suppose you are given 2 over here, 0 has been shifted to 2. Since you are given 1 only, 0 has been shifted to 1 without changing the shape of the graph. Same shape only. orange and blue and same shape only. Now we can go for that modulus of x plus 1, that is orange color. X plus 1 has been added with x. 1 has been added with x means here first one, C has been added with x, causes the shift to the left. So from here, from blue, it has been shifted to the left by 1 unit. To the left by 1 unit means 0 becomes minus 1. Correct? Without changing the shape. So green color, blue color and orange color, the shape and all same. They differ only by 1 unit. So minus 1 means shifting towards the right hand side by 1 unit. Plus 1 means shifting towards the left hand side by 1 unit. That's all. This is all called translation. It is given clearly here. F of x equal to modulus of x minus 1 causes the graph of the function shift to the right for 1 unit. Already I told you. F of x equal to modulus of x plus 1 causes the graph of the function f of x equal to modulus x shift to the left for 1 unit. Now the third part, dilation. So far we have discussed reflection and translation. Now the third part, dilation. Listen carefully. Dilation is also a transformation which causes the curve stretches, expands, another name expands, or compresses, another name contracts. Multiplying a function by a positive constant vertically stretches or compresses its graph. That is, the graph moves away from x-axis or towards x-axis. If the positive constant is greater than 1, the graph moves away from the x-axis. The positive constant is less than 1, the graph moves towards the x-axis. By seeing that example, you can easily understand the concept, what is given in the dilation. Please listen carefully. Here, we are going to discuss about 3 graphs. One is f of x equal to x squared, and f of x equal to half x squared, and f of x that is equal to 2x squared. This is the original graph, f of x equal to x squared. That half has been multiplied with x squared. Here half is less than 1. Here 2 has been multiplied with x squared. 2 is greater than 1. Okay. Now f of x equal to x squared, that is a blue color graph. It's a parabola only. Now f of x equal to half x squared, the orange color graph. Half which is less than 1. But what is given here? F of x equal to half x squared causes the graph of the function f of x squared, f of x equal to x squared stretches towards the x-axis. So this graph has been stretched towards x-axis, stretches towards x-axis. Since the multiplying factor half which is less than 1, it is given clearly. The positive constant is less than 1, the graph moves towards x-axis. The blue color graph moves towards x-axis. That means stretches towards x-axis. Understand? Now, third one, f of x equal to 2x squared given. No, f of x equal to 2x squared causes the graph of the function f of x equal to x squared, this is a given graph, compresses towards y-axis. Compresses towards y-axis, that is, moves away from x-axis. See, look at that. Green color graph, that is y that is equal to 2x squared. Here 2 is greater than 1 means that blue color graph is compressed towards y-axis. Orange color one expands, that is that moving towards x-axis, and green color is moving towards y-axis, that is compressing, because 2 which is greater than 1. What is given here? The positive constant is greater than 1. The graph moves away from x-axis. That means moves towards y-axis. Moves away from x-axis means moving towards y-axis. Okay. So you have to learn everything. You must be knowing the concept well. Then only can understand that exercise 1.4. So, we have discussed reflection, translation and dilation. The next video I will be teaching that exercise 1.4. Thank you, children.